MDM4U 2.6 Measures of Spread, Lesson 2 of 2. A percentile measures the number of values in a set that are less than or equal to a particular value. For example, if Desiree scored in the 95th percentile on the EQAO, this means that she did better than or equal to 95% of the people who wrote the test. So this is a comparison to the rest of the data. So her score, we don't know the actual score that she got on the test or what the test is out of, but we know that she did better than 95% of other test takers. Percentile rank can be given by this formula. This is going to tell you where it is positioned. So P is the percentile that you're looking for, N is the size of the sample, and R is the rank of the percentile. So when you do this calculation, sometimes you will get a whole number. If R is a whole number, then the kth percentile is the rth element. So this will be listed in order from least to greatest, and you would count that many number of spaces over to find that's position or rank. If it is a decimal value, then the kth percentile is the midpoint of the two closest rank positions for R. So there are different definitions for the same concept, percentile, that you will see in various texts. This is the rule of thumb that I would like for you to use. It can differ from one course to the next, but let's try to use it in this example. We are given this data. Notice that it is in order, so we can find its position. The 40th percentile. The 40th percentile, we take 40 divided by 100, and there's how many elements? So 10 plus 10 plus 5 is 25 elements. 0.4 times 25 gives us the whole value 10. So that means that we need to count 10 positions over. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Therefore, our 40th percentile is 275. It is greater than or equal to 40% of the data in the set. Therefore, 275 is the 40th percentile. If we were to look at the 50th percentile, so still 25 elements multiplied by 50 over 100. Notice that will just give you the percentage as a decimal used for calculating. This ends up being a rank of 12.5. Well, that's between the 12th and the 13th element. So what we will do is look at the values of element number 12 and element number 13. So there's 10 in each row. So 11, 12, and 13. So 12 and 13. If we look at the midpoint between these, add 280 plus 285 and divide by 2, we get 282.5 is the value of the 50th percentile. So this value is above 50%, above or equal to 50% of the data. Next concept, z-scores. So this is a measure of spread as well. It's talking about the dispersion. A z-score is the number of standard deviations that a datum is from the mean. So if you look at this formula, we have a separate formula for the population and for a sample. Let's focus on the following first. The z-score is x minus mu. And if you recall from the previous lesson, this is a deviation, how far in actual distance a data value is from the mean. And when we divide by the standard deviation, which is like the average distance from the middle, it will be one indication of how rare a test statistic is. So let's take a look. A sample of 8 plants were measured in centimeters. Determine the z-score of the data value 1. So what we need to do in order to be able to calculate the z-score, we have to know x minus mu, so we will need the mean of the set. In this case here, we have a sum of 24, and there are 8 elements. So the mean is 3. And we also need the standard deviation. So this is a little bit of work. Let's come up with the formula. S is equal to the square root of the sum of x minus x bar squared divided by n minus 1. We're using the n minus 1 because I explicitly stated a sample. So if you get really good and well practiced, you can do right in this step x minus x bar, which is 2 minus 3, which is -1 squared, and -1 squared is 1. So you can skip to just writing this column along with your data set to get this value. This is the objective for coming up with this table so that you can substitute into this equation. When you get that value, we have a standard deviation of 1.85. So the average distance from the middle is 1.85. And if we were to go back to our data values, the z-score of the data value 1. So the first thing that we'll need to do is look at our formula. Substituting in, our particular value that we're observing is 1 minus the sample mean, 3, gives us -2 as a deviation. When we divide by our standard deviation, it's telling us the number of standard deviations that it is away from the mean. So let's look at our result. A z-score of -1.08 indicates that it is 1 whole standard deviation to the left of the mean and 8% of a standard deviation to the left further. Notice the following. Z of 3, well, we said that 3 was our mean. So when we have a deviation of 0 caused by 3 being our data value we're observing, 3 being the mean that we had for the entire data set, it hasn't deviated at all. So it is a z-score of 0. Notice that for the z-score of 6, the value is to the right. We have a positive value in the numerator for our deviation, so it's to the right of the mean. And when we divide by 1.85, we find that it is +1. So 1 whole standard deviation to the right and 62% of an additional step to the right.